Let's talk about how processes are important for finding security problems on Linux systems. Processes are like programs. They run on systems and they sometimes leave clues behind if something bad is happening. If a process talks to another computer over network, that's something worth checking. So we're going to look at a simple process or a simple program and track what it's doing. We'll figure out how to spot it on the system. So in this system, we have a file called simple.c. You'll see there's an actual code file written in the programming language called C. And before we can use it, we need to compile it. Compile means converting this human readable code. So this is actually human readable code. And converting that file into something the computer can directly run, into a program. So we can do that with the command. So with this command, it turns the code of simple.c into an application if the GCC is installed. So I install GCC, the C compiler. And once it's installed, we can turn that code into a program. So a lot of time, people who create malware or hackers, they will use code files and they turn that into programs, into malicious software. So with this command, it turns code into the program. And now we can start it by simply typing /simple. And now it's running. So let's find out about this program. So we're going to open a new terminal. We're inside the same computer. And we're going to check running processes. So with this command, ps, it shows all the processes running on the computer. You see there's a lot of processes here. And in here, we find the program we just started, which could be malicious. Now, alternatively, if you don't want to go through this list, if you have many processes, you can also search within it. So you can say pipe, grep, and then whatever word you're looking for. So for example, the program is named simple, and you'll see the command we just typed, which is a program, and the program that is running. So with this command, you can filter out more easily. You can also filter by user, if you change it into the username, whatever username. But now we know the process number. So every process has a unique identifier, a unique number. You'll see here, this is the process, simple, and it has the unique identifier 2087. So it's the second one after the name. If we do PS, you'll see the first parameter here is the name, or the identifier, and the identifier is a unique number. So every program, if you start multiple of the same program, it has unique identifiers. So we can find out what the program is doing. For example, we can find out which files it's using. You can do it with the command lsof -p and then the process ID. Now, in order to have the process ID, simply search for it and then type the command again. And you'll see this program is using several resources on the system. You'll see it's using libc for C programs, something for the CPU. You'll see it's using this file on the disk. And so you can find some different things about a process by browsing the resources it's using. So with lsof, list open files. With the process ID, you can find out the different files it's using. So sometimes it might be using interesting files. In this case, what we can figure out is that the location of the program and that it's using the C library and also the CPU it's made for. You can find something from the memory and general information. So depending on the program, if it's a malicious program, it might be using a lot of files and you can then see that. Now you can also find out other things about it. Like for example, is it making any network connections? So then you add the -i for network connectivity, P for port numbers, and N for displaying the IP addresses, the internet addresses. So in this case, it doesn't have any of that. It doesn't use the internet other computers. With PSaux, you can see the different processes, but you don't see if they are connected to any other computers or to the internet. Like if we run it, we know which processes are running, who's running them, the process ID, the name of the program, but nothing else. For example, here we have a suspicious process. We know who's running it, but we don't know what does it connect to. We just know the name of the program. So we can find out the information about that. So we can find out detail with the command ls-off list open files, and then -i, -p, -n, where I shows the network activity, P shows the port numbers, so that's which line does they connect on, and N, which IP addresses, so which network addresses they are connected to. So if I press enter, we can now see the commands, the process ID, some other information, and we see that it's using the internet. This is our local address. You see a little arrow here, so it's connecting to this address on the internet. Now, malicious software or malware can connect to many different addresses. In this case, we know with this command, we can see all the open programs that connect to the internet. So we can find out if there's anything malicious going on, if there's any programs that connect to the internet. Attackers want to make sure they stay in the system. So once a hacker gets into your system, they want to stay in your system after breaking in. It is called persistence. So imagine a thief sneaking into your house. Instead of leaving, they create a secret key to come back anytime they want. So let's see how attackers do this on Linux system and how you can catch them. So one of the most basic tricks they can use is simply to add a new user to your system that only they know about. So they might run some commands like user add with administrator right, like this, and the name of the new user, whatever the name is called. So that's this command, and press enter, and now they created a new user for themselves. They can of course set their own password, and they might run commands like that to keep having access into the system. They might simply add some users that you might not expect, and then they can always use that to log into the system again. Now, you can find out if any user has been added or logged in with logs. So Linux keeps like a diary of everything that's happening on the system. For example, when it keeps activities of creating users and when they are logged in and so on. So there's a log file called var log outlog. So that's this file. And in this file, it shows all of the things that happened on the system regarding authentication. So if I press enter, you'll see a lot of things. It's a very long diary. So the computer keeps a diary of all the user activity. But we can filter through this. For example, maybe we're only interested in when users have been added. So we filter on user add. And now we see different users that have been added. So there's the user Frank that has been added, that's us. But if you check in this log, we see also the user hacker has been added, which has administrator rights. And we say the same for Bob here. That was the test one that we did, also administrator rights. So you can find out about any user that has been created on the system. So we simply can do it with this command, and it checks out or it tells you which user had been added to the system. You might also search for failed login. So you'll see if you search on failed, if you have a remote control of a Linux system in order to remote access using SSH, we can filter on it and see here we find out people who've been trying to log in to our system. So using this command. Now, we can also find out some more information. So Linux keeps the detailed files on users in the etc password directory or file. So that's etc passwords. And if I press enter, you'll see all the users on the system, but also system users. So there's a lot of them like no login. Those are not real users. So if I press enter, you'll see a lot of outputs and you'll see a lot of no login. So those are not actual real users. Those are just system or application users. the ones that are users can actually log in. So instead of having no login at the end, they have, for example, bash or sh. That's how you know they are users. If they have no login, then they are not actual users. So for example, root is a real user. It has been bash at the end, but daemon, it has no login, so that's not a real user. So this is another way you can find out information about users. You have the username, the user ID, the group ID, the name again, the folder they use for all their files, and the interface. So it can be bash, can be sh, can be C shell. If it's no login, that's not a real user. So they might simply add new users to your computer once they hacked your computer to keep access into your computer. Now, it's not the only way they can keep access into the computer, but it's one of the most simple ones and easy to check. To keep access into a system, and malware, it wants to stay on a system. So how do they do that? Well, another trick they can do to keep access into a system is using a cron job. A cron job is like a to-do list. It's like a task that repeats again and again. Now you can define several tasks to run repeatedly. And attackers often use this trick to make their program run again and again, whether it's malware or something else. So every user can have their own cron jobs. Hackers often add multiple users, and each of those users, they can have cron jobs. So they can really hide in many different places if there's a lot of users on the system. Want to see for your specific user? Let's see, who am I, to show your username. You can type the command cron-tab -e, and these are the tasks specifically for this user. So every user has their own jobs, their own to-do list for their user. And there in this file, they can define what should it do. For example, in this case, it starts virus program, and then at a specific time. So you'll see here month, hour, so you know, okay, this one starts at 1 p.m. or 1 a.m. And then every day of the week, the first day of the week, every month. So they can specify with this code when it is being started, and also what they start. So they might start malicious software or malware or reverse shell or something else repeatedly. But this is specific to this user. So just by removing, for example, in this one, if we would remove this virus.sh, which we can delete it or comment it out, and it's not gone from the system. There's still, the program might be running, so we can search for it. In this case, it's no longer running. But it might, because this cron job can be for every user, there might be other users who also have a cron job starting that malware. Now, there's also a general one on the administrator level, the root level, which is etc cron job. So if we take a look at that file, their cron jobs can also be defined. So in this file, so it can be on administrator level and for every user. That means that if you have some malware on your Linux system, well, one thing is simply to wipe the system and install again. But if you want to investigate, there can be several cron jobs on the system. So every user has their own cron job, and in the administrator level, so many ways they can hide in the system. So in this case, I show the output, and you'll see these are just for the administrator, but different jobs that run at specific times. So you'll see these run as root, as administrator, and the command they run, and you'll see here when they run with some explanation, minute, hour, and so on. So they might add themselves in the etc cron tab. They might add themselves on the user level with cron-tab -e. There's many ways that the malware or the hacker can hide in the system where the program is running automatically. So it could be a program that's simply malware, or a program that gives access into the system. It could even be that they always re-add themselves as a user into the system. So even if they are deleted, the automatically planned task adds themselves again as user. So there are many tricks they can do. But the main thing to remember from this video is the cron tab. You can define many cron jobs, which are like to-do lists that the computer does automatically. You've seen different ways that hackers gained access into the system. So one is simply they add a new user to the system, and the other was cron jobs. But there's another way they might keep access into the system. That's using services. A service is a program that runs in the background. So, for example, if you start your computer, some programs might start automatically. like a graphical interface, maybe some network manager and other programs that run in the background automatically without you doing anything. Now, attackers can create their own fake service to stay hidden, and that service could then start their malware or give them access into the computer. So on the Linux system, all the services are stored in the folder etc systemd system. So this folder, that's where all these services are stored. And if I list, you'll see many different services. So for example, we have some graphical thing here. We have dbus service, something for the monitor, network. You can find different services. If you go up one folder, you can find some configuration files. So they might hide services in this folder. In this case, for example, there's hidden.service. So that's rather suspicious. They might pick a name that's not so suspicious. Now, if we take a look in the file, you'll see that this service, it starts automatically if it fails. And what it does, it runs this program, the virus.sh. Now, of course, in the real world, they might not be so obvious. They might pick another name, but it could be that there are services in this folder in etc systemd system that are not legit, that are malicious. So by doing this, every time the computer restarts, their program starts again. And there are some commands to make that happen. So for first, they will try to reload it. So they reload that system. Then they add their own service. And they might also start their system service right away. Because Linux computers might not restart so often and they don't want to wait, so they might start it right away. And now they have access into the system using that hidden service. Or if it's malware, then it's running in the background. And with the status, they can see if it is actually running. So in this case, it's not running, it failed to run. And that's the idea of these services. So they can hide in your system, in that folder. They can create their own services, for in this case, the hidden.service. And they can then, it runs automatically every time they start. So not at a specific time, but every time the computer starts, their malware or their access into the system then starts. So if you run the command without any parameters, sudo systemctl, you see all these services currently running on the computer. And with the arrow keys, you can browse through them. You see a lot of different services that are running in the background. And it might be there is some suspicious service in there. So anything anything that wasn't there when the system was installed that is suspicious. There might be legitimate ones, like something that's installed onto the computer for legitimate reasons. But hackers also use this technique of services to gain access into the system, and malware uses it to stay in the system. Attackers often leave traces on the disk, just like someone taking a walk leaves footprints in the mud. On Linux systems, if a hacker gets access to a system or malicious software, malware, then they leave footprints on your computer, because Linux system register almost everything. So by looking, if you know where to look, you can uncover what they've done. So let's explore that. So first, we'll take a look at some important files on a Linux system, for example, the password file. And that file stores information about the user, the groups, and how they log in, their folders, and so on. So we can find out its etc password. So we can list the contents of this file, or we can investigate when it's last been changed. So by typing stat in front of the file, you can find out when is it last modified, changed, when was it last accessed, and so on. So if you didn't add anything recently, it might be suspicious. Now the same thing can be done for the etc shadow file. That's where the passwords are actually stored for the users. Now they're not stored in readable text, so simply reading the file won't give you the passwords. They're stored in encrypted format, but it does hold all the passwords. So that's the etc shadow file. Now, on Linux system, there's also the etc group file, stores information about which groups are there. For example, there's the sudo group, and any one part of the sudo group can run commands as administrator. So that's in the file etc group. You'll see many different groups on the system. If you're part of the sudo group, you can then run administrator commands. You can check the file etc sudoers. So this tells you who can run sudo. So attackers might give themselves this power. And you'll see to view this file, we need to be administrator. In this case, we can do sudo. We can run it as administrator. And you'll see here, the root user can run things as administrator, but also anyone else. So for this specific system, anyone can run the sudo commands, but it depends on the configuration of etc sudoers. So if you want to secure your system, you might want to disable that and only have root be able to run administrator commands, or an alternative is only one specific user can do it. But by default on this system, anyone has the sudo permissions. So those are some important files that you can check on the Linux system in the etc directory that tell you information like about what's going on in the system regarding users and groups. Another way that or thing you want to check is software installed on the system. In this case, we're on a Ubuntu system. So if I type uname -a, you'll see we are on a Ubuntu Linux system. So it's very similar to Debian system in terms of packages. But there are other Linux systems. So this video is specific for Ubuntu or Debian-based systems. Now, you can find out which software is installed by typing the command dpkg -l. That lists all the software installed on your system. So in this case, you can find different programs like base files, bash, and other ones. And with the arrow keys, you can move around. And you'll see the name of the program, the version, the type of system it's made for, but also a description. So in this case, we have a package that is not suspicious at all, called access package. It's a software that might have been installed by the attacker. Now, how do we know what software is installed recently? Well, we can check the log files. So if we clear this output with Ctrl-L, we then can type grep install, and then the log file for installation packages, which is dpkg.log. So if we run this command, we can find out all the software that's been installed recently. So you'll see here all the software that's installed. GCC has been installed. And libgcc, if we scroll back further, you can find SSH is installed, OpenSSH server, and so on. This is the installation log. So that's with this command, we can find out what's been installed recently onto the system. And you'll see access package has been installed recently. So in the last entry here, we see access package is installed. Now you might search on your system for that file. So it might be that it's still there. For example, here we have access package.deb. That's how we know it's there. And it might be a suspicious file. So you can open Debian package, the deb packages, and look inside them. So for example, in this case, it's already extracted. And we enter the folder. And you'll see a file post install. That's what it does or installs after installing. And in this case, it just outputs. It's simply a bash script that outputs something suspicious. But it could be some malware, or it could give a hacker access into the system. So by checking the software you install, you can find out if there's anything suspicious. So that's the command dpkg -l. With that command, you can see everything installed on your computer. Might want to check if it's installed recently. So that's with this command, see if it's installed recently. If it is, it might be worth investigating like the last packages to see if there's anything unusual in there. Linux keeps a diary of everything that happens on the computer, and it does so in log files. So they're different files where it stores, records everything that happens. So they're incredibly useful for keeping an eye on the system, spotting attacks, investigating problems, and so on. They tell you what's happening and where it might be going wrong. So it can help you with security. So let's go over some important log files. If we go into the var log directory, that's where you find all the log files. So that's var log, and you see many different log files on there. So one of the important one is the syslog file. So that's this log file. And it records general system activity, including errors, warnings, updates, services, applications, and so on. So it's helpful because it identifies problem across the entire system. It can also be a sign of malicious services being installed or unusual activities. So with this command, we can take a look at the file. Now it directly outputs the entire file, so you would have to use the scroll wheel to scroll up and down. Or alternatively, you add the pipe less, then you can browse through it by the arrow keys. So you can browse through it and see what's been going on in the system. Now, this is not the only file. There's another file called messages. So that file is similar to syslog, but it's more system level events and kernel events. So the first file, it also tells you about services that are being run, and this is more general. So it's useful for hardware issues and things like that. There's the authentication log. So this is super useful because it tracks login attempts. So both successful logins and failed logins, if a user has been created. And yeah, it's very useful to check the authentication log file. So in that file, we can see different users are created, if they're logged in, and so on. So those are some important files. In this file, it's important to check for failed logins. For example, we can say grep failed, and we see there's the failed attack. Number of logins. It could be useful if it's, for example, outside of office hours. If there's login that didn't happen during office hours. It can be also unexpected network activities or errors in there. So very useful file. And also new users, of course. So if a new user has been added, we can also list that. So it can be useful to keep a track of that file, out.log, to see if anything suspicious happens. Now, you can also look for suspicious network addresses. For example, it might be that a new network connection was accepted from a user, but that the network address is suspicious. So you can find out the network addresses in there as well. Maybe they log in from a strange location. There can be system-wide warnings. So you can search for warning in the var syslog. So in this case, there's no warnings on this system. And if you want, you can keep an eye on log files in real time by typing tail -f and then the name of the file you want to check continuously. For example, let's say you want to continuously check syslog. So now it keeps watching the syslog, and anytime a new event happens, you'll see it appear here. So log files matter because it tells you what's happened after the attack, and also, for example, who tries to get into your system, what actions were taking, and if something went wrong. So checking the log files, if you know what to look for, you can fix those problems. Behind the scenes, Linux is recording a lot of things. So you saw before with log files, it records everything that's going on the system. But there's another file, or another type of log, which is the bash history file. It records all the commands a user does on the computer. So investigators often look at this file because it can reveal what file actions were taken on the system, like running malicious commands or anything else. So where do you find that? If I simply list the files in the folder, we don't find that bash history file. This is because it's a hidden file. If I type -al, you can see the hidden files. And you'll see we have a bunch of hidden files and hidden folders. One of them is the bash history file that stores all the commands that have been done by the user, in this case Frank, because we are in the folder home Frank. So those are all the commands Frank user has run. Now, it's important to know that each user has their own history file. So there's no general one. Every user has their own file. And if there's been malicious things going on in a system, you'll have to investigate all of the files for the different users. So if you want to see everything that the user did, we can simply take a look at the bash history file. So remember there's a dot in front of it because it's a hidden file. And those are all the commands run by the user Frank. So you might look in this file for any suspicious commands. So in this case, there's nothing really suspicious going on, but there can be multiple users. For example, maybe in the administrator user, let's say we output that one. And you'll see, okay, this one doesn't have the bash history file and the root user never logged in. But for every user, you can check in the home folder. In this case, there's only Frank as a user. For every user, it has its own bash history file, and that stores all the commands the user tried. So you might look for access to sensitive files in the etc directory, downloading anything like with wget or curl. If they try to become administrator, so for example, we take a look at bash history. We see them here, they run a command as administrator, but they didn't really become administrator. And probably they could try to delete evidence like with the rm command, deleting log files. So with the bash history can be another useful file to try to find out any suspicious thing going on. Now you can also monitor in real time. For example, tail -f, whatever user. And now it's watching in real time what commands that the user is running. So you could find out if there's anything suspicious going on in real time even. So hackers, they use bash history quite a lot. For example, they might create backdoors, download malware, edit configuration files, and anything suspicious that they might be doing, it might get stored in the bash history. Now, they might also, of course, try to delete the bash history file or modify it if they know about that file. So it's like a gold mine for investigation, this bash history file. It tells you the story of what happens for that specific user and also the attack tools, the methods, and their calls.